Yeah, good morning, good afternoon, good evening. Depends on when and where you are watching me. Yeah, let me welcome you all into this video. In this video, we'll be talking about matrices and determinants. Uh, we'll look at what matrix is all about. We'll look at some types, not all the types of matrices. We will solve examples, yeah, and we'll now move further to know the meaning of determinants. That is what we'll be looking at in this video. So I want you to pay attentive and listen very well and put your mind here so that anything we are going to learn and discuss here, it will not escape your memory. Okay, thank you. Okay, let's go. Okay, yeah. Topic. Matrices and determinants. Amen. Okay. Matrices and determinants. Yeah, determinants. Okay, yeah. It's simple as ABC. Amen. Uh, I'm going to break matrices down for you. We'll look at it in real life. I know very well that some of you, why am I coming to learn mathematics? Is mathematics important in my field of study? Yeah, let me tell you that mathematics is very important. Do you know that anything you do, you apply mathematics unknown to you? I'm going to use real life examples so that you will know that anything you are doing, you apply mathematics. Okay, let us consider what we mean by matrix. Amen? Yeah. Matrix. Let me use real life as an example. When we say matrix, yeah, do you know that in the bank they use matrix to do a lot of things? I will explain. If you are a military personnel or Air Force, Navy, Army, whichever force you belong to, you apply matrices. Two of us. Yeah, you may not know, but as a mathematician, I have to prove to you to know that you apply matrices. Even in your offices, you apply matrices. Yeah, most especially microfinance banks and loan banks. You people apply matrices. How? Okay, let's start with banks. You know very well that when you go to bank, if the bank, inside the bank, uh, the crowd is much, do you know that any other person that will come to the bank, they will ask him to wait, two of us. Even inside the bank too, they apply matrices. How? If there is much crowd, instead of attending to customers rampantly, that is one person want to be the first, trying to struggle to attend to him or her. You must first attend to me, the other one too. That is, the customers are competing to be the first person to be attended to. You know, because of that, they will now apply matrices. How? They will now ask them to form a line, assuming the line is the line 1, we have 1, 2, 3, 4. Line 2, 5, 6, 7, 8, line 3, 3, 8, 9, 10. Yeah, so for more accuracy, they will form a line to identify one after another, true or false, so that they know who they are dealing with. Yeah, because of to avoid that uh, crowdy competition. Is that clear? So now, without one telling, this is line 1, line 2, line 3. Without one telling you, for that, we are going to what? Bracket it, true or false. You know, the bracket means it does not exceed here and it does not exceed here, true or false. You discover that it will stop at some point. The number will stop at some point. So that process means is what? Matrix. That is matrix. Likewise, even in the military, if they want to go for their parade, they apply the same method. When they are doing their parade, you discover that the parade looks so interesting. Why? Because of the form they apply. That is, they apply matrix whenever they are marching or they want to parade Independent Day, true or false. The same thing, Air Force, police, and the rest. So they apply what is called matrix to do whatever thing they are doing. Yeah. So now this matrix is called 3 by 4. Why? Because we call this row, we call this column whenever you come across matrix. So it means this is the column line, this is the row, true or false. This is the column, amen. Yeah. Then this is row, true or false. Yeah. When you go to physics, we call this line horizontal line, we call this line vertical line, true or false. So what am I trying to say is we call this matrix 3 by 4. Why? Because the straight line, that is the horizontal line, it has 4 members, 4 people, 1, 2, 3, 4. While the vertical, this is line, that is the column, has 3 people, 1, 2, 3. So it is called 3 by what? 4 matrix. So whenever you come across matrix of this one, it is known as 3 by 4 or 3 by, you can write it this way, whichever way you want to write it. But sometimes they can even write it like this. It implies that 3 by 4. So take note. So what if you have matrix of this form? Matrix of this form. This is called 2 by 2. The row and the columns are what? Equal. So this is known as 2 by 2 matrix or 2, 2. Yeah. Or 2 by 2, whichever way. So take note. What if we have 1, 2, 3, 4, 5, 8, 9, 10. This is called a 3 by 3 matrix. Is that clear? It's either this way or 3 by 3 or 3 by 3 matrix. So take it. So now you can now see that we are able to define a matrix in real life, true or false. Yeah. So if someone asks you, you don't need to cram. You can explain what matrix is all about. Look at, if you go to some banks, you discover, ATMs, you discover that you will see only one straight line, true or false. That straight line, if we remove this, this is how the line will be, true or false. So this is a row matrix. So it means that ATM stand, they apply row matrix. Do you understand? A row matrix. Okay, so now let's define what matrix is all about. Amen? Okay, what matrix is all about. Yeah, so matrix is a rectangular array of numbers is a rectangular array of numbers enclosed by a pair of brackets. A pair of brackets. Yeah. Amen. So you discover that, look at it. It could be either 1, 2, 3, 4. This is a matrix. If we want to name it matrix A. So you discover that a rectangular array of numbers, look at it. It is in a rectangular form, true or false? Enclosed by a pair, look at it, a pair of what? Brackets. So we call this a matrix. So in case you are asked to define matrix, mathematically matrix can be defined as either A or B. Matrix A or B equals to, you write it this way, no problem. Okay, so now let us look at types of matrices. Types, amen, types of matrices. Okay, sorry. Okay, one, we have row matrix. Row matrix. Yeah. When we say row matrix, you know, I have explained it before. If you recall, row matrix is of the form. It means it has only one row. That is, A is equals to A, B, C. We call this a row matrix. Let us apply it in real life. If you go to some ATM, you will see that you only discover a straight line, true or false. So that straight line, mathematically, we refer it as what? Row matrix. Do you agree with me? Are you following? Okay. That is a row matrix, or it can be written this way: 1, 2, 3. Mind you, matrix can never be in this form. Yeah. Why? Because matrix does not have comma. So take note. Is that clear? Because some teachers or lecturers are very funny. They may say true or false. This is a matrix. B equals to this. True or false? It's false. It is not a matrix. Take note. Is that clear? Okay. So that is that. Then we consider 1, 2, column matrix. Amen. When we say column matrix is of this form: A, B, C, vertically. Amen. Yeah. This is a column matrix. Yeah, the column matrix is, let us have it in this form. The column matrix, assuming you are building a house and the workers are using ladder to climb up straight, get to the top of the building. It means they are applying a column matrix. Do you understand? That is a column matrix, that is vertical. Is that clear? Vertical is a column matrix. Do you understand? Or let's look at it this way. You know, in a lift, the lift will not just carry one. Okay, let's forget about the lift. But here, uh, the ladder I'm talking about to access to the top of a particular building by a number of people or persons, you are applying what? A column matrix. Is that clear? Okay. Yes. Let's look at it this way. Or let's look at it this way. A column matrix, when the cube is more than 1, you are still applying column matrix. That is, you go to a bank and you discover that the queue is like this, either 1, 2, 3, 5, and there is another queue again, 8, 9, 11, 12. This is our row, isn't it? You discover that we have 2 columns. Column 1, we have column 2, we have column 3, we have column 4, 2 of us. So if you go to bank and the line is more than 2 lines, this is line 1, line 2. Note that they apply both row matrix and what? Column matrix. And that refers to what? A matrix. So take note. Okay, that is that. Yeah. So far, so good. Now let's consider zero matrix. Zero matrix. Amen. Zero matrix. When we say zero matrix is of this form. It is either like this, or it is of this form. This is a zero matrix. Is that clear? Take note. Then we'll also look at square matrix. Square matrix. When we say square matrix, you don't need a prophet to tell you. When we say square, you know, I used to tell you that sometimes you apply mathematics, but unknown to you that is mathematics you are applying. Most especially civil engineers, they apply this square to put up a structure, 2 of us, because the structure must be what? Square. Otherwise, something will happen, isn't it? Yeah. So when we say square matrix, it means all the matrices, both the row and the column are what? Equal. That is, square matrix example is, let us have a matrix 0, 2, 2, 1. This is a square matrix. Why? Because you discover that the row 1, 2, then the column 1, 2. It means they are all equal. Or let's have another one more example: 1, 0, 1, 2, 1, 0, 3, 2, 1. This 1, 2 is also a square matrix. So this is how a square matrix is. Is that clear? Do you agree with me? Okay. So now let's look at identity or unity matrix. 4, 5, identity or unity matrix. Amen. Okay. Unity matrix. When we say identity or unity, when we say unity means one. It means your matrix it contains what? Only one. So if we have matrix of this form, 1 0 0 0 1 0 0 0 1. This is how identity matrix is. This is a 3 by 3 identity matrix. Then 2 by 2 identity matrix is 1 0 0 1. This is a 2 by 2 identity matrix. Then if we want to have 4 by 4 identity matrix, A is equals to 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Yeah, this is a 4 by 4 identity matrix. So take note. Is that clear? Then I'll stop at scalar matrix. Is that clear? Scalar matrix 6. Scalar matrix. Amen. When we say scalar, a matrix is scalar. It implies that the diagonal, we can refer this one as a scalar matrix. Why? Because the diagonals contain the same number. True or false? We have one here, we have one here. Now when we say diagonal, diagonal is like this. Yeah. And we can also refer identity matrix as what? A diagonal matrix. Is that clear? Yeah. So it implies that, example, yeah, 0 4. This is a 2 by 2 scalar matrix. It can be 2 0 0 2. 2 by 2 at the scalar matrix. Let's have it in 3 by 3 scalar matrix. As an example, B is equals to 2 0 0 0 2 0 0 0 2. This is a 3 by 3 scalar matrix. This one, this is a 2 by 2 scalar matrix. So when you come across something, a matrix of this one, you don't need a prophet to tell you. The diagonal contains the same number. Is that clear? So that is that. So now we'll look at algebra of matrix. Algebra of what? Matrix. When we say algebra of matrix, we are talking about how we can add matrix, how we can subtract matrices, how we can multiply matrices. Then we solve some example. Okay, so far so good. Can I claim of this? So the rest, I want you to go and study the remaining types of matrix. Is that clear? Yeah. Algebra of matrix. Amen. Algebra of matrix. Algebra of matrix or matrices. Algebra of matrices. Okay. Now we'll consider one, addition of matrix. Addition, amen. Addition of matrix. Okay. Yeah. When we say addition of matrix, it's simple as ABC. How you can add, you know how to add. It's not difficult. It means we are adding matrices. That's just it. Is that clear? So when we say addition of matrix, it means we are going to add two given matrices. Let's look at example. Example. Amen. Example. Given a matrix A equals to 1, 2, 3, 4, and B equals to 0, 5, 6, 7, and it said find A plus B. It's simple as ABC. So it means we are going to add these two matrices. I'm going to break it down for you to understand it better. Is that clear? So now what you need to do is you write solution. You write solution. Matrix A is equals to 1, 2, 3, 4. B and B is equals to 0, 5, 6, 7. Yeah. Then A plus B will now be equals to matrix 1, 2, 3, 4. Amen. Plus matrix 0, 5, 6, and 7. Yeah. So for us to add this, is that clear? For us to add this, it means, look at it. Let me remind you of this. Assuming matrix A is A11, A12, A21, A22, amen? And B is, let's just say, B, amen? B11, B12, B21, B22, amen? Okay. So if we want to add A plus B, this implies that our A plus B will now be equals to A11, A12, A21, A22 plus B11, B12, B21, B22, amen? So if you want to add, it means A11 plus A, so our A plus B, amen, will now be equals to A11, amen, plus B11, yeah. Then A12, A12 plus B12, then A21 plus B21, then A22 plus B22. This is how to add a given matrix. So even if you are asked to subtract a given matrix, it means here will now be what? Minus. So in between them will be minus, here is minus, here is minus, here is minus. So now we want to apply the same thing here. Your A11 is what? 1, A12 is 2, A21 is 3, true or false? Yeah. A22 is 4. Then, and B11 is 0, B12 is 5, B21 is 6, and B22 is 7. True or false? So if we want to approach it this way, it implies that our A plus B will now be equals to, our A1 is what? A1 is 1. Look at it. So 1 plus B1 is 0. Then A2, look at it. A2 is 2 here, 2. Then our B2 here, B2 is 5 plus 5. Then A21, this is A21 is what? 3 plus B21 is 6, isn't it? Look at it here. 6. Then A22 is 4. 4 plus B22 is 7. So you can now see that it is not difficult, isn't it? I told you I'm going to break it down. So this will now be equal to 1 plus 0 is 1. 2 plus 5, 7. 3 plus 6, 9. Then 4 plus 7 is 11. So therefore, our A plus B is matrix A plus B is equal to 1, 7, 9, 11. Is it difficult? Yeah, this is how you are going to add the given matrices. Even if the given matrices are 3 by 3 matrices, it's the same approach. If it is a 3 by 3 matrix, it means this is how your matrix A will be. A11, A12, A13, A21, A22, A23, A31, A32, A33. Yeah. Then your B matrix B2, the same thing. So you just apply this procedure, then at the end of the day, you can obtain your answer. Is that clear? Okay. So that is an addition of matrix. That is a matrix for you. Sometimes you may not see it in this form here. They might convert it to X. Then here will be Y. Sometimes you will see Z like that. It's the same approach you will use. Is that clear? It's the same approach you will use to add up a given matrix. It means here will now be what? X, isn't it? Here will be what? Y. So it means here too will be X, here will be what? Y, here will be X, here will be Y, here will be X, amen, here will be what? Y. So not necessarily you must see A and B. Is that clear? Technique. So that is an addition of matrix. Okay. Now let's consider subtraction of matrix. Is that clear? Okay. I'll only clean here. Subtraction of matrix. Subtraction of matrix. Amen. Okay. Subtraction of matrix. Yeah. Okay. So example, we will make use of the same example. Find A minus B. Amen. A minus B. Yeah. So the A minus B, now we are using X. So let's clean here. It's the same approach we will use. Is that clear? We'll make use of the same approach. Okay. Or I should leave this. It's the same approach, please. Is that clear? It's the same approach. I've said it before. So here will now be X minus Y. Notice X minus Y is equals to 1, 2, 3, 4, amen, minus 0, 5, 6, 7. Do you agree with me? So here X minus Y will now be equals to 1 minus 0, 2 minus 5, 3 minus 6, 4 minus 7. Yeah. So you discover that our x minus y matrix x minus y now, because 1 minus 0 is what? 1. 2 minus 5 minus 3. 3 minus 6 minus 3. Then 4 minus 7 minus 3. This is the answer. Is it difficult? Huh? Is it difficult? Is it difficult? No, it is not. Okay? Yeah. So, that is algebra of matrices. We'll consider subtraction, consider the addition. So now let us try to consider multiplication. Is that clear? Multiplication. Let us consider multiplication of matrix. You know very well that this is where we are going to find it difficult, most especially when you are not good at multiplication. But for the fact that you are here, I'm going to break it down for you to learn and understand it better. Is that clear? Okay. So that is that. Okay. So with this, I think you can solve any problem from matrix. Multiplication, amen. Multiplication of matrix. Okay. Let us go by example. Given a matrix, amen, A equals to 1, 3, 2, 5, and B equals to 0, 1, 2, 3. I will now say find or evaluate AB, matrix AB. Sometimes A times B is the same thing. They are telling you. Is that clear? It's the same thing. Okay. Yeah. So if excuse me, if we are to find AB, it's simple as ABC. We write solution. Solution. Our matrix A is equals to 1, 3, 2, 5. And matrix B is equals to 0, 1, 2, 3. True or false? Okay. So now our AB will now be equals to 1, 3, 2, 5 times 0, 1, 2, 3. Amen? Okay? So this is where the problem is. If you are not good at multiplication, you always find it difficult. For you to multiply this, let me have this. Let us take note of this. A11, A12, A2, A22. Amen. Yeah, this is a 2 by 2 matrix, and here 2 is a 2 by 2 matrix. Because after multiplication, this is how your matrix will look like. Is that clear? So now, for us to get A11, how can we get A11? Is, listen, this one, use this one to multiply this. Then plus, use this to multiply this. That is, this is rule. Okay, let me just fix it out. This is row 1, isn't it? For you to obtain A11, you use row 1 to multiply column 1 of B. So look at it. 1, 3 times 0, 2. Yeah, look at it. 1, 3 times 0, 2. So it will give you this. Is that clear? So now our AB is equals to, let's do it. So now 1 times 0. Okay, let's do it. 1 times 0 plus 3 times 2 plus 3 times 2. You've gotten here, true or false? Then, for us to get this, for us to get A12, it's the same approach we will use. That is 1, 3 multiply 1, 3. That is, first row will multiply the second row. That is, it means 1, 3. First row will multiply the second column of B. So it means 1, 3 times 1, 3. This is how it will be. So now, to obtain here, it means 1 times 1. 1 times 1. Then plus 3 times 3. 3 times 3. 1 times 1. Look at it. Plus 3 times 3. This is 3 times 3. I told you I'm not going to rush this. I'm going to take it step by step. Then for us to obtain here, A21, it's the same approach. Is that clear? For us to obtain here, we will use the same approach. That is, we are going to use row 2 to multiply column 1 of B. Is that clear? So it means now here will now be row 2 is 2, 5, isn't it? 2, 5, that is what to obtain here, times column 1, which is 0, 2. Is that clear? So now 2 times 0, that is to obtain here, now be 2 times 0 plus 5 times 2 plus 5 times 2. It means we have obtained here. Is that clear? Then the last but not the least, we have to obtain here. Do you agree with me? So for us to obtain here, the same approach, row 2 multiply column 2 of what? B. So row 2, this is row 2 times column 2 of B. It means 1, 3. So 2 times 1, 2 times 1 plus 5 times 3. 5 times 3. Amen? So you can now see that. You can now see. So now let us sum or subtract. Is that clear? Let us sum. Let us add. This will now be equals to 1 times 0 is 0. Let me take it step by step. Plus 3 times 2, 6. 1 times 1, 1. Plus what do you have here? Plus 3 times 3, 9. Then 2 times 0, 0. Amen. Plus 5 times 2, 10. 2 times 1, 2. Amen. Plus 5 times 3, 15. So you discover that by the time we add this, it means our A plus B. Therefore, our A plus, which is A times B, sorry, 0 plus 6, 6. 1 plus 9, 10. Then 0 plus 10, 10. 2 plus 15, 17. This is the answer. Is it difficult? Huh? Look at it. Look at how I took my time to explain this. Look at it. So this is how you are going to multiply two matrices. Is that clear? Do you agree with me? Okay. So that is that. So then it means we are done with algebra of matrices, but there are other algebra of matrices, but that one I will say on your own. You can go and study this, but the basis, I've done the basis. So with this one, I don't think you have any challenge in matrix. If you understand what we have done here, I don't think. Then let us now consider determinants. Is that clear? Let's consider determinants. Can I clean this? Let us consider determinants. Determinants. Let's close with determinants. Is that clear? Okay. Okay. Amen. Yeah. I can clean this, right? Let's close with determinants. Okay. Yeah. So, determinants could be written in this form of A and or in this form. Take note. Is that clear? Take note. So if you are given a matrix and they just say find look at this. This and this. They are telling you to find what? Determinants. Is that clear? They will not write find determinant of A. No. Because already is in determinant form. So they will only say find determinant of this matrix. But if it is not in determinant form, they will now say find the determinant of A. If A is equals to, you can now see 1, 2, 3, 4. You discover that it is not in determinant form. So take note. So if whenever you come across something like this, they are asking you to find the determinant. Is that clear? So now let us consider example how we can obtain determinant of matrix. Amen. Yeah. Example. Find the determinant. Amen. The determinant of A. If A is equals to A11, A12, A21, A22. Yeah. So at this point, what we need to do, we have to write solution. Amen. Write solution. Our A1, that is our matrix A is equals to A11, A12, A21, A22. Please, Malians, take note. You know that I'm not writing the matrix this way. A1, A, A21, A22. This one and this one, they are not the same thing. Please take note. The reason why some of you fail mathematics is as a result of this. Is that clear? So always take note. This one and this one. This one is A11, A12 times A12. While this one is A11, A12. Take notes, please. Very important. So if you have been given this to obtain the determinant of A, either you write A determinant is equals to what you will do. Use A11 to multiply A12, then minus A21 to multiply A22. Is that clear? I know you don't understand what I'm trying to say. Use A11 or A21 to multiply A11 minus use either A12 or A21 to multiply. That is A11 times A22, then minus either A21 times A12. This is the answer. This is the determinant of A. This is how to obtain determinant of a 2 by 2 matrix. Is that clear? Do you have any question? So now let us use values. Let's apply values. So I may say this is the formula of a determinant. Yeah. So let's make use of values. Let us have here 5, 10, 3, 4. Then we are asked to find, yeah. Okay, amen? Yeah. So we write solution, amen. Here will be A is equals to 5, 10, 3, and 4. Terminal 3 and 4. So our determinant of A will now be equals to, this is our A11, this is our A12, this is our A21, this is our A22. True or false? The formula, this is the formula A11 times A22 minus either A21 times A12. Whether you want to write it this way, A12 times A21. Multiplication is commutative, whichever way you want to do it, no problem. Even if you want to change this one this way, 2, 2, 1, 1, you don't have any challenge as long as multiplication is commutative. Okay, so now let's use this formula to find the determinant of this matrix. So your A11, where A11 is equals to 5, A12 is equals to 10, isn't it? A21 is equals to 3, and A22 is equals to what? 4, isn't it? So your A22 is 4, so here will be 4 times A11 is 5. What do we have here? Minus. Then A12 is what? A12 is 10. 10 times A21 is 3 times 3. So therefore, our determinant of A will now be equals to 4 times 5 is what? It's 20, amen? Then minus 10 times 3, 30. So therefore, our determinant, amen, will now be equals to 20 minus 30 is going to give us minus 10. Is it difficult? Is it difficult? This is how to obtain a 2 by 2 determinants. So now let me show you how you can obtain a 3 by 3 determinant. Is that clear? So let's look at a 3 by 3 determinant. Okay? Yeah. I hope you are satisfied with this lecture. I don't think you have any challenge having a counter with me here in mathematics. I don't think you have any challenge. If you have any challenge, it means you have a very serious problem. Okay, let's have a 3 by 3 matrix. 1, 2, 4, 0, 3, 5, 1, yeah, 0. Okay. Find the determinant of A if A is equals to this. Yeah, this is a 3 by 3 matrix. Is that clear? So now we want to consider 3 by how to obtain 3 by 3 determinant of a 3 by 3 matrix. It's simple as ABC. But here we have some challenges. We are going to let's write solution. A will now be equals to 1, 2, 3. Let me write it up here. Solution. Amen. 4, 0, 3, 5, 1, 0. Amen. Since it is a 3 by 3 matrix, we must solve, take note of plus, minus, plus. Amen. Yeah, let's take note of this. So whenever we are solving a 3 by 3 matrix, so it means what we are going to do for us to obtain the determinant of a 3 by 3 matrix, it means our determinant of A will now be equals to, let us obtain determinant of 1. Here we are using 1, 2, 3. Is that clear? So here is 1. Let us consider 1. Note that 1 is plus, true or false? Yeah, 1 is plus, so the determinant of 1 will now be, if you want to find the determinant of 1, what you need to do is close the row of 1, then close the column of 1. What are you saying? Sorry? You are now saying 0, 3, 1, 0. True or false? Yeah, so the determinant of 1 will now be 0, 3, 1, 0. Okay? Then 2 is what? Negative. So here will be 2. Let us find the determinant of 2. The same approach. Amen. Determinant of 2 will now be, you close the row of 2 and the column of 2. So what are you saying now? You are saying 4, 3, 5, 0. True or false? So 4, amen. 4, 3, 5, 0. Then here 3 is what? Plus. Since it is a 3 by 3 matrix, so plus 3. Find the determinant of 3. Amen. Okay. Let us find the determinant of 3. So here you close the row of 3 and the column of 3. What are you saying? 4, 0, 5, 1. 4, 0, 5, 1. 4, 0, 5, 1. Do you agree with me? Do you agree with me? Okay. So far so good. Here will now be equals to 1. Then we are now going to take the determinant. Now we have transformed it into what? A 2 by 2 matrix. True or false? So what we will do here is we are going to apply the same method. Use this one to multiply, use this, any answer, use it to multiply the one. The same thing applicable, use this one to multiply, use this one minus, use this one to multiply. Any result you obtain from this determinant, use it to multiply whatever that is outside. Do you understand? So now, let's do it this way. You are not going to put it in determinant form. So this one times this, go back to our previous example. It means 0 times 0 minus 1 times 3. Yeah. True or false? Then minus 2, open bracket, 0 times 4 or 4 times 0 minus 5 times 3. Yeah. Plus 3, 1 times 4 or 4 times 1, whichever way, minus 5 times 0. Do you agree with me? So if you agree with me, amen, if you agree with me, okay, if you agree with me, it means this is how we are going to do it. Yeah, this is how we are going to do it. Our determinant of A now be equals to 0 times 0, 0. 1 minus 1 times 3 minus 3. So 0 minus, okay, let me just break it down. 0 minus 3 here. This matrix will be 0 minus 3. Then here, minus 2, amen. 4 times 0 is 0. Then minus 5 times 3 minus 15. Amen. Then what do we have here? Plus 3, open brackets. 4 times 1 is 4. Then minus 5 times 0 is minus 0. Yeah. So I said I will break it down for you. 0 minus 3 minus 3. Take note. Then what we have? Minus 2, open bracket. 0 minus 15 minus 15 plus 3. 4 minus 0 is 4. Amen. Okay. So our determinant A will now be equals to, use this one to multiply the determinant, which is what? Minus 3. So 1 times minus 3 is going to give us minus 3. Then minus 2 times minus 15 is going to give us plus 30. True or false? Then plus 3 times 4 is going to give us 12. Amen. Okay. So our determinant of A is equals to minus 30 plus 30 plus 12 is going to give us 42, isn't it? So now minus 3 plus 42. Therefore, our determinant of A will now be equals to 39. Yeah, this is how we are going to solve this type of matrix to obtain the determinant of a 3 by 3 matrix. So this is how you are going to solve it. I don't think or you don't understand, or you still have you are still finding it difficult. Okay, so that is that. Then we'll now look at matrix equation. Is that clear? I will end, because the reason why I want us to consider determinant first before we look at matrix equation, because we'll make use of the determinant to obtain any matrix, any given value. Is that clear? So far so good. So can I clean this? Then we look at one example in matrix equation, although it's still under determinant. I can clean this, right? Okay. Yeah. Okay. Yeah, so far so good. Amen. So let's look at one example. We close with the example matrix in matrix equation. Let's look at one example. Okay. Find the value. Amen. Find the value of x. Find the value of x if we have a matrix of this form: x minus 1, 1, then 2 plus x and 3 equals to 8. Yeah. If you come across questions like this is a matrix equation, true or false. So I'm going to show you how to solve this type of matrix. So let's write solution. Amen. X minus 1, 1, 2 plus x, 2, then equals to 8. Simple as ABC. Amen. So what we need to do is for us to consider the determinants. You know how to find the determinant. We've done it before. So this one multiply this one minus this one multiply this. So the left answer will now be x minus 1 times 2, true or false. Then minus 1 times 2 plus x. Amen. Then this is equals to what? 8. Yeah. So you discover that you have reduced this matrix to a linear equation. True or false? Yeah. Sometimes you have a matrix, you reduce it to what? A quadratic equation. Sometimes a polynomial. Yeah. But I'm just using this one as an example so that you'll be able to find or reduce matrix to what? Quadratic. Then you use any method, either formula method or completing the square method or factorization method. Is that clear? So let us multiply out 2 times x. We are going to have 2x. 2 times minus 2 minus 2. Note that there is minus here. So minus 1. Carry along this minus. Any value that will be here. Minus 1 times 2 is going to give us minus 2. Then minus 1 times x minus x. Then this is equals to what? 8. So you don't need a prophet to tell you. We collect like terms. When we collect like terms, amen, collect like terms. Okay? Collect like terms. When we collect like terms, this is 2x minus x. Then minus 2 minus 2 minus 4. Okay, minus 4. So minus 4, or let me just arrange it. First, 2x minus x minus 4 equals to 8. So we collect like terms. If we collect like terms, we are going to have 2x minus x is equals to 8. This crosses, minus 4 crosses the sign of equality, becomes what? Plus 4. So our 2, okay, our 2x minus x is going to give us x. Then this is equals to 8 plus 4 is going to give us 12. So this is how to reduce matrix to a linear equation. And at the end of the day, you'll be, oh, sorry, find the value of x. Sorry, made a mistake here. If, sorry, find the value of x if, yeah, find the value of x if matrix is equals to this. So subsequently you will come across questions like this, even in advanced algebra. Those of you that are doing engineering, you will see in advanced algebra deeper questions that are more than this and that. So this is where we are going to end and close. So I think with this, I don't think you have any challenge in determining, as long as matrix is consigned, because I've done a lot of solvings here. I've done a lot of solvings here, so I don't think you have any challenge. But sometimes they may say find 2a if that is a is equals to 0, 1, 2, 4. Do you know that it's simple as ABC? So for you to find this, sometimes you come across questions like this. You write matrix 0, 1, 2, 4. Amen? So 2a means you use 2 to multiply matrix A. So 2, open bracket, 0, 1, 2, 4. Then you will now see 2a will now be equals to 2 times 0. That is, this is what you will do. 2 times 0, then 2 times 1, 2 times 2, 2 times 4. Amen? 2 times 4. Then our 2a will now be equals to 2 times 0, 0, 2 times 1, 2, 2 times 2, 4, 2 times 4, 8. Yeah. So this will be the answer. So this is how you are going to look at it. So let me drop one assignment here, so that on your own you can do it. If A is equals to 0, 1, 2, 1, and C is equals to matrix C is equals to 2, 4, minus 1, 0. Find, amen, 2a plus 3c. Yeah. Go and solve this problem. Is that clear? Let me just give you an hint. What you need to do is clean here. Let me give you an hint. What you need to do is our 2a plus 3c is equals to 2 matrix 1, 0, 2, 1, then plus 3 matrix 2, 4, minus 1, 0. This is how you are going to do it. I've solved it for you, just for you to multiply and add. You know how to add matrices. Add them, then you have your matrix. Thank you for your patience. I wish you all the best.